Welcome students. In the last lecture we have seen about the two methods of drawing an ellipse with the help of directress focus method as well as with the help of rectangle method. In this lecture we will see about the parabola, how it can be drawn with the help of directress focus method as well as rectangle method. Now you will see that this is the problem statement that a point F is 50 millimeter from the vertical straight line AB. Draw the locus of point P moving in a plane such that it always remains equidistant from the point F and line AB. Now here in this case, this is a very close similar procedure to an ellipse, but having certain slight changes. Now here two input things are given. A vertical straight line AB is nothing but the directress and F is nothing but the focus. Distance between them is 50 millimeter. This is the one input, and another input in the form of an eccentricity is given, which is nothing but equal to 1. In the form of condition it is given. You can concentrate here at this particular line. Okay, always remains equidistant from point F and line AB. Now the procedure is very simple. Like draw AB, that is nothing but the directress line, find out any midpoint at a suitable point on AB, and draw another CX line which is perpendicular to AB, which is representing an axis line for this particular parabola. Now after that, from C you need to locate F, this particular point, which is very important one. It can be located at a distance of 50. You need to give the dimension here, which is not shown. That is very important one. Now after this you have to locate V. Now as here eccentricity is equal to 1, that means VF upon this VC distance is equal to 1. That means VF is equal to VC. That means for 50 millimeter this distance between C and F, V should be located at a distance of 25 millimeter. So mark a point on CX line at a distance of 25 millimeter either from F or 25 millimeter from C1, and the same thing you will get V. Through V, draw a vertical line which will be parallel to this particular directress. Then in your compass, take distance equal to VF, make an arc here which will cut this vertical line through V at a point K, join CK and extend it. Now here, like in case of ellipse, we have drawn 145-degree line to meet this particular CK extended at one particular point, so that we will get the another vertex here, which is very true in case of an ellipse because it is a closed curve. But here parabola is not a closed curve, it is an open-ended curve, so it is not necessary to get that particular 45-degree line. If you try to draw the 45-degree line here, it will never meet CK extended and it will be going parallel to that. Now whatever the distance which is available here after V as well as F here, you can divide this into any number of equal parts. Here it has been taken 1, 2, 3, 4, 5. So 5 points are there. You can take 7 points, you can take 9 points, but 5 points are sufficient one. Name all these points from 1 to 5. Then through 1, 2, 3, 4, 5, draw the vertical lines parallel to this directress line as well as to this VK extended, so that it will meet the CK extended line at points 1 dash, 2 dash, 3 dash, 4 dash and 5 dash. Now at these particular points, wherever this intersecting points you are getting, like 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, we need to make use of this particular points. Now here F will be always your center, 1 dash will be the distance, so that you can get all these points. 1 dash will be the distance, F will be the center. Mark on this 1 dash projector, will be getting both the points on both the sides. Here 2 dash will be the distance, F will be the center. Mark on this projector of 2 dash, you will get second P2 other 2 points on both on both the sides of this axis. 3 dash will be the distance, F will be the center, you will get these 2 points. 4 dash will be the distance, F will be the center, you will get these 2 points. 5 dash will be the distance, F will be the center, you will get this another 2 points. So in this way you can get P1 dash, P2 dash, P3 dash, P4 dash, P5 dash, as well as P1, P2, P3, P4 and P5. Here the points has not been named, but you need to name it properly. And now through these points from V to this particular P5 dash as well as from V to this P5, join it with the help of a smooth freehand curve, and then try to make it fair after all with the help of a French curve. So in this way, a very simple procedure to draw a parabola. Another thing which is nothing but the next one, that is parabola with the help of rectangle method. Now in this case, parabola with the help of rectangle method, very simple thing. A simple statement is there. It can be given. Now this is a somewhat application oriented problem, that a ball thrown in air attains 100-meter height and covers horizontal distance of 150 meter on ground. Draw the path of the ball, which is nothing but the projectile. Okay, now here in this case, as the distance maximum height attained by the ball is of 100 millimeter, which is nothing but this minor axis of this parabola, as well as this major axis of the parabola as nothing but this 150 millimeter distance, 150 meter distance. Now these distances are given in meters. You need to use here a scale. That means nothing but here we cannot represent meters, 100 meters and 150 meters on our drawing paper or drawing sheet. So you need to use here a scale which represents this 150 millimeter as well as this 100 millimeter in proper manner. So here you can take, if suppose this you are taking as 15 suppose 150 millimeter, then you can term it as whatever the 1 millimeter here represents 1 meter in actual case. That particular scale you can write it down here. It depends on you. The scale can be dependent. It may change individual to individual, but it should be an appropriate one so that you can represent it on a plane of paper in a very proper manner. So this 150 here in this case, you need to first of all construct a rectangle having this particular length as 150 and height as 100. So this distance, suppose it is E, F, G and H. So EF will be equal to 150 and this particular distance, that is suppose E, F, G, H. So EH will be equal to 150 and this EF will be equal to 100. You can name this particular center point, that is from this one as this is suppose EH. So it should be A, B accordingly. So in this case, in this way you can draw first of all a rectangle which is having the length equal to 150 and height equal to 100 millimeter. Now again I'm repeating here, scale should be used here. If suppose you are taking this as 150 millimeter, so 1 millimeter represents 1 meter. Here for this one you have to take this as 10 millimeter. So in that case 1 millimeter, this is 100 millimeter actually. So here 1 millimeter will represent the 1 meter. So the same scale is applicable for both the dimensions. Now after making this particular rectangle, it's very easier one to draw this particular curve. Now how it can be drawn? Now here the half part of the curve we will draw first of all. So here in this case, this is E, F, G and H point, already I have told you, and this is A and B. So we will divide this EB into equal number of parts. How many equal number of parts? This is 1, 2, 3, 4 and 4, 5 and 6 number of equal parts. In the similar way we have divided this EB into 6 equal number of parts. In a similar way we have to divide this EF into same 1, 2, 3, 4, 5, 6 equal number of parts. Now it is somewhat tedious one. If it is tedious one to divide this into equal number of parts, use our dividing a line into equal number of parts graphical method, which is very useful one. From this draw a 45-degree line as well as from this draw a 45-degree line. Divide this into 6 number of equal parts, join last point to this point and draw the parallel lines through remaining divided points. You will get all these points. The same can be repeated for this EB. Now here, after getting all this divisions on this side as well as this side, as well as from this H to B as well as this G to H, for what is remaining one, is nothing but you need to join these particular points. So here is AB. So join this 1 point to A, 2 to A, 3 to A, 4 to A, 5 to A. And in the similar way, 1 to A, 2 to A, 3 to A, 4 to A, and 5 to A. Now after this one, whatever the divisible points you are having on this A to B as well as H to B, draw the vertical lines parallel to this particular height of this parabola, whatever is given 100 meter. Here in this case, as per your scale. So draw these vertical lines. Now all these lines should be drawn in very continuous thin manner so that it will be looking like a projector line. This a vertical line which is drawn through one, which will be meeting 1A. This is the first point on the curve. Through two vertical lines should be drawn, which will be meeting at 2A, which will be second point. The third vertical line which will be drawn through 3, which will be meeting to 3A, which will be third point. A vertical line drawn through 4, which will be meeting to 4A, fourth point. A fifth line which will be drawn through point number 5, which will be meeting to 5A, which will be the fifth point. In this similar way here, a point which will be drawn through 5 and it will be intersecting with A5. Again, a point will be a vertical line will be drawn through 4, it will be intersecting with A4. Point a line will be drawn through, vertical line will be drawn through 3, it will be intersecting with A3, as well as in the similar manner A2 and A1. Whatever the intersecting point you are getting here, P1, P2, P3, P4, P5, P6, P7, P8, P9, P10, draw a smooth curve with a free hand and then later on make it fair with the help of a French curve so that you will get an ellipse, which is nothing but a projectile, you can say, from one location E to the another location H for throwing the ball in the air from one position to the another position, which is following a projectile in a parabolic path. So this is very important one. In this way you can draw a parabola with the help of a rectangle method. I hope both these things are very clear to you as far as parabola by directrix focus method and parabola by rectangle method. In this only these two things are given: the total distance traveled by that particular ball, or if suppose it may be a stone or it may be any another object, and whatever the maximum height which is achieved by that particular ball. If it is given in millimeters, there is no need to go for scaling, but if it is given in meters, it is very difficult one, so we have to reduce the scale, and therefore we have used the reduction type of scale here, which already have discussed in my second or third lecture in the classroom session. So I hope this is very clear to you. Now I'll be moving to the hyperbola, which is a third conic curve. Hyperbola with the help of directrix focus method can be drawn in this manner. This is the problem statement. Draw a conic section when the distance between its focus and directrix is equal to 75 millimeter and the eccentricity is equal to 3/2. Here also the two things are given. The distance between directrix and focus 75 millimeter and eccentricity is 3/2, which is greater than 1. The procedure is very simple again, likewise our parabola, but here different thing is how to locate V. That is very important one. Again, draw AB, which is the directrix line. Find out the midpoint of AB. Draw CX. Here X is not shown actually, which is an axis line for the conic curve, that is hyperbola in this case. Locate F point, which is the distance of 75 millimeter in this case, so CF is 75 millimeter. Now here in between this C and F we need to locate this V. How to locate this V? It depends upon this eccentricity 3/2. Now this 3/2 means what? Out of 75 millimeter, third part is of VF and second part is of VC, that is VF upon VC, which is nothing but the formula for an eccentricity of this particular hyperbola. So here in this case actually how it will be taken, or another thing is that this is 3/2, that means total 5 parts of 75 millimeter you are having here. So in this case, how these 5 parts can be you can say shown here, that is very important one. Now here it is 45/30, that can be also taken here. So VF is 45 and VC is 30, or you can make total 5 equal number of parts of CF, the 3 parts goes from V to F, and the 2 parts goes from B to C. So in this manner, VF, this distance is equal to 45 millimeter, and VC is this distance is equal to 20 millimeter. A very big difference I just wanted to tell you. In case of ellipse, V is closer to F. In case of parabola, V is at the middle of C and F. And in case of hyperbola, V is closer to C. Try to remember this one, which is very, very important one. Now after this one, after getting V here, take this draw a vertical line through V, which is nothing but, in earlier case also we have drawn it. Then from V to F, take distance in your compass, VF, V will be the center. Make an arc here, which will be cutting at point E. Join a line, join C and E, or draw a line which will be joining C and E and extend it. Okay, now here also if you try to draw the 45-degree line through F, it will never meet to the CE extended, so that we will not get another V1 point, which is nothing but the closed point in case of an ellipse. So this is again an open-ended curve. Now here in case of parabola, we have divided this into 5 number of parts, we have divided this VF extended line, that is axis line, into 5 number of parts, but here it can be divided into 3 also. So here 1, 2, 3, to focus it has been divided 1 through 1, 2 and 3, these divisible points we have drawn. If we have to draw these vertical lines which will meet the C extended at 1 dash through 2, it will be drawn in vertical manner like this one, which will be meeting to CE, and this manner that at 2 dash through 3 it will be drawn. 3 and F, that is focus, are one and the same thing, so it will be the 3 dash. Now here we will be getting 1, 1 dash, 2, 2 dash and 3, 3 dash. These are the points. What is the remaining one is that take distance equal to 1, 1 dash. F will be the center. Mark on 1, 1 dash projector. Take distance equal to 2, 2 dash. F will be the center. Mark on 2, 2 dash projector. 3, 3 dash will be the distance in your compass. F will be the center. Mark on 3, 3 dash projector. And thus in this way, if you take the 4 number of points, 5 number of points, accordingly you will get 4, 4 dash, 5, 5 dash, and point number another points on the respective vertical projectors. So in this way, whatever this P1 dash, P2 dash, P3 dash, which are not named here, you need to name it. This is P1, P2 and P3, these points. Join from V to this all these points, join from V to all these points with the help of a freehand curve. Then try to use the French curve for joining all these points, and try to draw this particular curve, which is nothing but the hyperbola. So I hope this is very clear to you as far as the ellipse, parabola and drawing at it. Now this hyperbola is considered one. Now we will go to the next one, that is hyperbola by rectangle method. Now hyperbola by rectangle method, now this is the solution which is drawn by Akanksha. I have just referred her solution here, and this problem which is from FE B Kekebag Institute of Engineering Education and Research, Nasik, from that particular institute. FEB, who is having a very good handwriting as well as drawing skills. So here in this rectangle method for hyperbola, this double ordinate method is these are the input things. Double ordinate is given, abscissa. This method is also known as ordinate abscissa method. So therefore this is abscissa is given, transverse axis is given. So all these things are generally given here. So you need to, here what is important one is that from this O you need to draw an axis line. On this axis line, this OV distance is generally equal to half of the transverse axis. Here transverse axis is 160 millimeters, so we need to take it as 80 millimeter. Here it will be the, from this one we need to draw this particular rectangle which is having the dimensions from this one. This is 60 millimeter, which is nothing but the abscissa, and this vertical line you need to draw it, which is nothing but the double ordinate, that is 100 millimeters. So 50 from this side and 50 from this side as far as axis is considered one. So you need to construct here this particular rectangle which is having the dimensions of 60 as well as 100 millimeter. Now in this case, this O is also playing a very vital role, from which we are getting the various points on this particular curve. Now here whatever this rectangle is drawn, which is nothing but of E, F, G, H, as well as this OV, which is nothing but half of the transverse axis, and this VD here, which will be the extended part of this axis. Now here what we have to do is we have to divide this EF as well as this FD into equal number of parts. Here it has been divided into 1, 2, 3, 4, 5, as well as this is 1, 2, 3, 4, 5. So you might have used here, instead of that dividing the line into equal number of parts, C might have used the dividers with the help of scale, and C has divided into this particular 5 equal number of parts. Now join whatever these FD points are there to this O, like O4, O3, O2, O1, and this particular V which is available on, that is the point on vertex, that is the point on curve, to this V1 dash, V2 dash, V3 dash, V4 dash. Now here this V1 dash will be intersecting with this O1, which will be the first point. V2 dash will be intersecting with O2, which will be the second point. V3 dash will be intersecting with the O3, which will be third point. V4 dash will be intersecting with V4, O4, which will be the fourth point, and in the similar way you have to create all these points. Now after this one, you can repeat the procedure in the bottom manner also, that is from O to this, division of this one as well as division of this one. This is the first alternative available with you. The second alternative is that from whatever this P1, P2, P3 and P4, this particular points, you will draw the vertical projectors in downward direction parallel to this abscissa, and then just mark this, whatever this distance is available on this side, whatever this distance is available on this side, whatever this perpendicular distance is available on this side, whatever this perpendicular distance is available on this side. So in this way, we have done in the same thing in case of an ellipse, which will be drawn with the help of rectangle method. The same procedure you need to repeat, and in this way you can complete the hyperbola by rectangle method, or it is also known as abscissa ordinate method. So I think up till now there was only once the question was asked on this particular topic in SPVU examination, which is also very important one. So try to study this particular topic also, as well as rectangle method as well as directrix focus method for hyperbola. So I think friends, I have tried to cover the basic procedure of drawing ellipse in case of my first video, as well as parabola and hyperbola by the help of directrix focus method and rectangle method. So I hope this is very important one for all of you to refer this particular video, which is important one. For this one, I have just referred the books like Andy Butt and VM Panchal by engineering drawing, our Mr. Zole's book of engineering drawing, as well as whatever this particular figure, this particular drawing which was drawn by Akanksha, as well as whatever some PPTs or whatever the drawings I have used one that are from the Harsh Patel, that was one particular fellow who has uploaded his PPT on internet, and have used from that one. So thank you very much for all this particular people who have just given some data for making this particular video as well as this presentation. So thank you very much. Okay, we will again meet to have the discussion as well as explanation about the other remaining curves in the next video. Thank you very much.